Hi Math 20, welcome back to another lesson. All right, so we're moving on to 1.5 compounding periods. We did in the last lesson, we looked at what compound interest was and how it was different than simple interest. Compounding periods are really important. This is one that can really trip people up, but it's also a really important one because this is something that you're going to use practically throughout your life. You know that question of when am I ever going to use this? This is one that you will use a fair bit, whether you're looking at getting a car loan or a mortgage, something where you're going to be borrowing money, or if you're going to be investing money and trying to make money, compound interest comes into play a lot. And a lot of people just go into these things and they don't even know what the final cost is going to be. They don't know how to calculate compound interest. They just take the car loan that they get and they go, okay, well, I guess that's what my payments are going to be. This is really an important skill to have. So I'm glad that you're here for this one. So let's just go ahead and get started. So to the beginning here, you've got your try these. I want you to go ahead and work through these, make sure you can solve them properly. It's again, really just looking at order of operations. So make sure I'll give you the answers, but go ahead and work these out. So 48, this one will be 61.44. 6.75, and this one will be 784. Out of all of them, this one will maybe be the trickiest because you have to remember to do everything inside. Well, both of these, do everything inside the bracket and remember your order of operations. So in this one, you do what's in the brackets, then you do it to the power of 3. In this one, you would have to first do your division question here, then add it, and then do what's outside the brackets. So, all right, so let's go ahead and take a look here. Interest rates. Interest rates are usually expressed as a rate for 1 year. This is often the way this will be if you see a simple interest question. It'll be like this much per year, but they're compounded differently. So compounding is what you saw in the last lesson, how it keeps adding on. Remember that? So when you see the word compound, you know you're going to a compound interest, but then you have to look for your compound period. So annually is once a year. Semi-annually is twice a year. Quarterly, it's just a year divided by 4, right? Quarterly. Monthly, that's going to be 12 times a year. Weekly, 52. Daily, 365. So pretty straightforward. So they're looking at one immediate question here. So Kevin wants to invest the money he earns teaching piano lessons. He has an online bank with a high interest savings account, and this is their rate of 1.8% per year. The interest rate is compounded monthly. So you know this is your yearly interest, but it's compounded monthly. So it's going to, what we saw in that last lesson, is going to add on to itself 12 times. So they're wanting to figure what's the monthly rate and how often his money will be compounded in 5 years. This is just to really think about what this means. So what is the monthly interest rate? So the monthly rate, they're just remember how to convert to a decimal. So 1.08 over 100, which is the same as 0.018. And so per year, 0.018 over a year is the same as 1 year divided by 12 months. So there's just our conversion there. So you've got 0.018 divided by 12 once you put that together. So times 1 divided by 12. And that's going to work out, once you calculate it, to 0.0015 per month. And so how many times will that interest be compounded in 5 years? So you know how many times this is per month. So 12 months in a year times 5 years equals 60. So in 5 years, you're going to have 60 compound times that it's compounded. So that's just an idea of how to think about how many times that's actually going to be happening. And let's work this through in some examples. All right, so Cheryl has a high-rise building in Vancouver. So here's the key points. So she's got $40,000 that she's going to be investing, or $40,000 that she's got in a reserve fund. So she invested 20,000 of it into an account that pays 1.8% per year compounded semi-annually. And there's $20,000 into an account. So same amount, 1.8 per year, but this time it's compounded daily. So the only difference in these two things is how many compound periods you've got. So how does the interest earned on each investment compare after 3 years? Solution A, what is the value of the investment with a semi-annual compounding? All right, so this is the first example. So we've got our compound interest formula. So our amount is our principal times, or in the brackets, 1 plus your I for your interest, and then your N for the number of times. And this is where it's going to come in differently because of your compound periods. So the first one, your principal is 20,000. Now 1 plus your interest, already converted. Semi-annual. So how many times per year is semi-annual? 2 times per year. So you've got 2. So it's your interest twice a year. And then the number of compound periods, 3 years with 2 times per year. So this, you have to remember when your compound periods, you have to have it underneath your interest because that's how many times it is per year, times up here for your number of compound times its total is how many years as well. So in this case now that's going to work out to, you should be able to do this on your calculator, but inside the bracket here. So first you would do your interest divided by 2 and then add the 1 onto it. So you'll have this together would be 0.8, like 0.18 is 0.009 and then plus the 1. So 1.009 and then 2 times 3 is 6. Once you work this through, you should come up with the answer of $21,104.59 once it's rounded. So 21,104.59. And then if we scroll down, let's take a look at what happens with compounding daily. So daily compounding, it's got your hint here, compounded daily is 365 times. So start with the same, she's investing the same amount into this one, $20,000. You have your same interest. The 1 is a constant, it's always there. You've got your interest that's the same as the one above. This time, it's compounded 365 times. So you need to do your interest and how many times it's compounded in that year. And then how many compound periods do you have? 365 times 3. So this worked out will be $20,000. Inside the bracket, you've got 1 point. This is going to be a little bit long. 0.000493. And then 365 times 3 is going to be 1,095. This is where, this is a long one. Remember I said keep your numbers on your calculator as much as you can. Don't clear it and then round it. Leave the rounding till the end. This number is actually a lot longer. There's way more to it. You're going to have a lot more of an exact answer if you don't round. Keep that number in there. So do everything in the brackets first, then do it to the power of 1095, and then you can multiply the $20,000. There's the steps that you can use to keep your value in your calculator the whole way through. In the end, you should have an answer of $21,109.66. So it's not really a big deal, a big difference between the two. How does the interest earned on each investment compare? So if we start here, 21,000. So take your larger number first, which was the compounded daily, 109.66, and then minus the smaller number, which was the 3 years. So 21,104.59. So your difference is only going to be $5.07. But what's really important to think about is long-term and bigger numbers like that could be a bigger difference in the end, depending if this was a 20-year investment, if you were paying off a mortgage, if you had $100,000. It's just good to be aware that the amount of compounding periods is going to make a difference. In this case, it was only $5, but it's going to add up. So that the big takeaway I want you to come away from this is remembering the compound period that goes underneath your interest and then also has to go on the outside of the bracket. Whenever I see mistakes in this lesson, and then reflected onto the test or the final, that's where people get tripped up. If you have any questions, please get a hold of me. And that's everything for this lesson. So go ahead and get going in your workbook and let me know if you have any trouble. Okay, thanks for watching.